Welcome to the DIY Honda Garage channel. In this presentation, we will focus on the diagnostic trouble code DTC P0125, which indicates an ECT, Engine Coolant Temperature, Sensor 1 malfunction or slow response in the 2008 to 2012 Honda Accord. The ECT sensor is critical for measuring the temperature of the engine coolant, and its readings are essential for proper engine management and fuel efficiency. This DTC can trigger if the ECT sensor fails to provide accurate temperature data to the Engine Control Module, ECM, or Powertrain Control Module, PCM. The location of ECT Sensor 1 is typically near the engine block, often on or near the thermostat housing. This understanding forms the foundation for troubleshooting and rectifying the associated issues. The DTC P0125 indicates that the ECT Sensor 1 is malfunctioning or responding slowly. This sensor plays a vital role in monitoring the engine's coolant temperature, which is essential for optimizing engine performance and emissions. The sensor's readings are transmitted to the ECM or PCM, which adjusts the air-fuel mixture and ignition timing based on temperature. It is usually situated close to the thermostat, which regulates the engine's coolant flow. A malfunction here can lead to poor engine performance, increased emissions, or even overheating. It's crucial to understand that this error may not just be due to a faulty sensor, but could also stem from other related components or wiring issues. There are several potential causes for the DTC P0125 indicating an ECT Sensor 1 malfunction. Firstly, poor connections or wiring issues between the ECT Sensor 1, ECT Sensor 2, and the ECM or PCM can lead to erroneous readings. If these connections are not secure, the sensors may not relay accurate data, triggering the DTC. Secondly, loose terminals can also contribute to intermittent connection, leading to sensor malfunctions. Another cause could be a faulty ECT sensor itself, requiring replacement to restore functionality. Additionally, a malfunction in the thermostat can affect coolant flow and temperature readings, further complicating the issue. Each of these factors should be assessed during the troubleshooting process to ensure a comprehensive approach. When experiencing the DTC P0125, you may notice several symptoms. The most evident is the illumination of the check engine light on the dashboard, alerting the driver to a potential issue with the engine management system. Additionally, you may experience engine performance issues, such as rough idle, poor acceleration, or stalling, due to improper air-fuel mixture adjustments prompted by inaccurate coolant temperature readings. Increased emissions may also occur, as the engine may run inefficiently in an attempt to compensate for the faulty data. Moreover, there can be heating problems in the engine, potentially leading to overheating if not addressed promptly. Recognizing these symptoms early is crucial to prevent further complications and ensure vehicle longevity. The first troubleshooting step for DTC P0125 requires starting the engine and allowing it to idle for at least 5 minutes. This warm-up period is critical, as it enables the engine and its components to reach an operational state, allowing the sensors to provide accurate readings. Following this, you should check the Engine Coolant Temperature ECT Sensor 1 data using the Honda Diagnostics System, HDS. This system helps in viewing live data and diagnostic trouble codes, allowing for a more precise diagnosis. Pay special attention to whether the temperature reading is around 0 degrees Fahrenheit, minus 18 degrees Celsius or less. If it shows this reading, it suggests a sensor malfunction. Otherwise, you will proceed to the next step for further diagnosis. In this step of the troubleshooting process for DTC P0125, your focus will shift to evaluating ECT sensor 1. If the initial reading was at or below 0 degrees Fahrenheit, indicating a malfunction, check for poor connections or loose terminals at ECT sensor 1 and ECT sensor 2, along with the ECM or PCM, which processes the sensor signals. Use a multimeter to test the continuity and integrity of the connections. If all connections appear adequate, the next logical step is to replace ECT sensor 1, as it may not be functioning correctly. Ensuring all connectors are secure and free from corrosion is essential for the continued accuracy of temperature readings. This assessment will help in pinpointing whether the parts are faulty or if other hidden issues exist. This step involves turning the ignition switch to the lock 0 position, effectively powering down the system. Afterward, allow the engine to cool to a temperature of 104 degrees Fahrenheit, 40 degrees Celsius, or less. This cooling period is essential as it allows for accurate ECT sensor readings when the engine is restarted. Once the engine is at a suitable temperature, restart the engine and let it idle. It's critical to closely monitor the performance of ECT sensor 1 during this period to note its response after cooling. This step also prepares the system for the next checks, focusing on verifying that the ECT sensor 2 reading aligns with expectations. Discrepancies at this point will guide further troubleshooting endeavors. After restarting the engine, you will monitor the data from ECT sensor 2. Specifically, check if it also reads around 158 degrees Fahrenheit or 70 degrees Celsius, as this is critical to the verification of both sensors' accuracy. If ECT sensor 2 shows approximately the same temperature, the sensors are likely functioning properly at this moment. However, if ECT sensor 2 does not reflect a matching temperature, it could indicate an intermittent failure or a problem with the connections between the ECT sensors and the ECM or PCM. This step helps in establishing whether the fault is with ECT sensor 1 alone or if other components might contribute to the inconsistency in readings. Understanding sensor interaction is vital in diagnosing the overall system health. In this troubleshooting step, the focus shifts to assessing the thermostat's condition in relation to DTC P0125. The thermostat plays a fundamental role in regulating engine coolant flow and temperature. A malfunctioning thermostat could significantly affect the ECT system's performance, leading to incorrect data. Check to see if the thermostat appears operational and without blockage or leakage. If the thermostat fails to meet its operational requirements, it should be replaced. If, however, the thermostat is functioning correctly, it's vital to revisit the earlier checks on connections and terminals around ECT sensor 1, ECT sensor 2, and the ECM or PCM. Evaluating this system is crucial for ensuring accurate temperature reading and overall engine performance. Following the thermostat verification, it's time to reset the ECM, Engine Control Module, or PCM, Powertrain Control Module, using the Honda Diagnostic System, HDS. Start by turning the ignition switch to the on, I call it position, without starting the engine. Once there, use the HDS to reset the ECM or PCM to clear any stored fault codes, including DTC P0125. This step is essential to ensure that any previous data does not affect current performance assessments. After performing the reset, turn the ignition back to lock 0 to complete the procedure. This reset helps in refreshing the system and prepares it for accurate temperature readings once you proceed to start the engine again. The final troubleshooting step involves a repeat of the cooling and monitoring process. Allow the engine to cool again to 104 degrees Fahrenheit, 40 degrees Celsius, to ensure the most accurate readings. Once at this temperature, restart the engine and monitor the ECT sensor 1 and sensor 2. Both sensors should read about 158 degrees Fahrenheit, 70 degrees Celsius. If they do, it indicates that the troublesome system is likely functioning correctly following the repairs and resets. If the readings do not match yet again, this suggests that your troubleshooting is now complete, confirming the potential for new fault codes to arise or indicating unrecognized failures elsewhere in the system. Documenting these findings is crucial for ongoing diagnoses or repairs in the future. Upon completing the troubleshooting steps for DTC P0125, final verification is required to ensure repairs have resolved the underlying issues. First, recheck all connections associated with ECT sensor 1, ECT sensor 2, and the ECM or PCM to ensure they are secure and free of corrosion. Next, confirm that both ECT sensors are functioning correctly by reviewing their data compared against expected values. Clear codes once you ascertain that all connections are intact and allow the vehicle to run to verify that the DTC does not reappear. Conduct a retest of the system to affirm that engine temperature readings are consistent and reliable. This verification is crucial for ensuring the vehicle is properly restored to optimal operating conditions, preventing future issues in the ECT system. To prevent issues related to DTC P0125 in the future, it is essential to implement a regimen of preventive maintenance on the ECT system and associated components. Begin by regularly checking the ECT sensors for accuracy and any signs of wear or damage. Keeping an eye on the condition of the wiring can avoid intermittent failures or shorts, which are common culprits in sensor malfunctions. Additionally, ensure that coolant levels are consistently maintained at optimal levels, as low coolant can lead to overheating and sensor inaccuracies. Schedule periodic inspections of the thermostat as part of the vehicle's overall maintenance routine to prevent unexpected failures. These measures can significantly extend the life of the engine and associated systems, providing greater reliability for the driver. In summary, the DTC P0125 points towards a malfunction within the ECT Sensor 1 system and highlights the importance of maintaining the engine's cooling system. Close monitoring of the ECT sensors is paramount, as accurate temperature readings are necessary for optimal engine performance and efficiency. Conducting regular preventive checks can forestall potential issues, ensuring lasting functionality of all components. Should any symptoms or codes arise, the outlined troubleshooting steps provide a systematic process for diagnosing and correcting the fault. Ultimately, addressing issues promptly not only enhances vehicle performance, but also contributes to a safer and more efficient driving experience. Taking these proactive measures will help in maintaining the Honda Accord's integrity across its lifespan. Please like and subscribe to the channel. See you next time.